A contest calls for you to push a 300 kilogram bobsled from rest on wet snow for 5 meters to see how fast you can make it go. If you push with a force of 800 newtons and get it up to 4 meters per second, how much thermal energy was created in the bottom of the bobsled and the snow? So, this is a problem we're going to solve with our ideas of energy and work. And if we look at the problem, we can see right away in what we're given the strategy we're probably going to want to use to solve it. So, we see that we're given a force that we're pushing this bobsled and a distance over which we're pushing it. So if we think about the fact that work equals force times distance, we can see that we'll figure out how much energy we're putting into the system, which will not include ourselves in, and that work will go into kinetic, which we can figure out, and thermal. So let's define our system. And that's going to be the bobsled and the snow. Now let's draw our bobsled. Here we are pushing it with a force of 800 newtons. Sorry. 800 newtons, and it is a 300 kilogram bobsled. X initial is going to be 0 meters. V initial is going to be 0 meters per second. X final is going to be 5 meters. And V final is going to be 4 meters per second. So let's figure out how much work we're going to be doing on the system. So we're going to be pushing with a force of 800 newtons over 5 meters. So it's going to come out to 4,000 joules. 4,000 joules of work we're putting in. So let's look at this equation. So delta K, it looks like the system's going to be gaining kinetic energy because we can see that V final is bigger than V initial. There's going to be no change in delta U. There's going to be no change in gravitational potential. There's no spring involved. We got to be careful here because while we will be burning chemical energy pushing the bobsled, we're not a part of the system. And so there will be a gain in thermal energy. That's what we're trying to figure out, how much thermal energy is created in the bottom of the bobsled in the snow. So let's set this up. So 4,000 joules is going to be equal to delta K plus delta ETH. So K final minus K initial plus ETH final minus ETH initial. So 4,000 joules, those are zeros. 4,000 joules. So K final, let's plug in some stuff to figure out what that'll be. So 1/2 mass is 300 kilograms times velocity squared. So the final velocity is going to be 4.0 meters per second squared minus K initial is going to be 0. And then ETH final is what we're trying to find. So we're going to have ETH initial be 0. So let's solve this out. And if we punch this in, we're going to find that this should equal 2,400 joules plus ETH final equals 4,000 joules. And we'll subtract it, and we'll find that 1,600 joules equals ETH final. So that's how much thermal energy is created between the bottom of the bobsled and the snow when we push with a force of 800 newtons over 5 meters. So let's go back and check to see if we got everything we need here. So we got a diagram, explicit indication of the system, solution beginning from fundamental equations. So we've got that. Proper units, significant figures.